can't fucking believe I'm doing this. Oh no, global, we have to get away. Hit the... What the fuck did I write? Quantum polyethanator turbo drive before the Zimzorps dequantize us with quantum beams. Quantum beam, quantum science for its beams. My god. I hate myself. Quantum physics is the new field of physics which directly throws everything we know about modern science out the window with the bathwater. Particles are whack. The forces are whack. The people who look at them, whack. Essentially, it's the whack physics, but it's also the physics of the smallest particles that we have discovered, and from it we get freaky shenanigans such as string theory and Firefly. But it's not complicated. Well, it is, but it isn't. Quantum physics is centered around these quantum particles that have been discovered and are on this table called the Standard Model. Ta-da! This table contains every type of visible particle in the known universe, which is pretty neat. It also breaks them up to the 4 groups with 2 major factions. Quarks, leptons, gauge bosons, and the shit we don't know. Essentially, quarks and leptons are both fermions. They exist with... I'll define them later. Meanwhile, gauge bosons and this yellow brick is all bosons. All of them have a mass, a charge, and a spin, which determines exactly what they are, what they can interact with. Yeah, end of video. Oh, right, let me get this table. Alright, this table is way better at explaining stuff because it has numbers on it. Starting with the spin because it's the coolest. The spin is one of the quantum particles. It determines... It's a trait of these quantum particles. It pretty much states whether this particle is going to obey the Pauli exclusion principle and whether it's a boson or a fermion. See, fermions only have half spins, which means they cannot pass through other matter. They obey the Pauli exclusion principle. Meanwhile, bosons have full spins and essentially just flip the birds all matter and drives right through them. And I'll get to you in a second. Essentially, quantum spin is just a property of every quantum particle. Like how the sky is just blue and the grass is just bad. It's a property which dictates a trait about it. No quantum particles are actually spinning because it's not something the particle does, it's a fact of what a particle is. The reason why this trait is called spin is because it's the short form way of saying internal angular momentum. Now, to explain the mass of a particle, we're going to have to start breaking down how mass holds a different meaning in this context. I'm sure everybody's seen this fucking equation written just about everywhere. E equals mc squared, look, I'm safe. No. It actually holds real big significance instead of just being the science equation. It is an equation written by Albert Einstein, which describes the equivalent relationship between mass and energy, called the mass-energy equivalence relationship. And it explains how energy is simply a given mass multiplied by the speed of light squared. So the mass of one quantum particle can be found by dividing its energy in electron volts by c squared. This means all that quantum particles are measured in electron volts divided by c squared, because using kilograms is far too huge of a scale. But all particles have a mass, with the only exception being the gluon and the photon, because the photon travels at the speed of light. For it to do that, it cannot have mass, or else it would require infinite energy. And the gluon is the particle which carries the strong nuclear force between 2 particles, so there's also that. And yeah, other than that, everything has mass. Got it? Good. Last up, we got the charge of a particle, which determines which quantum particles can attach to which other quantum particles. See, particles come in charges of positive 2/3, negative 1/3, -1, and 0. And charge is the big kahuna of these particle traits, since when you start intermingling them, you really actually get to see these traits justify why they're described as they are and why they're called what they are. Let's look at an example. Protons are particles within the nucleus that have a positive charge. They are always made up of 3 quarks, but depending on the mass of the proton, exactly which quarks they are will differ. The lightest proton will be comprised of 2 up quarks and 1 down quark to get a total combined charge of positive 1. So essentially, 2/3 plus 2/3 take away 1/3 equals 3/3 of 1. These quarks are held together with 3 gluons, which hold these quarks together, you know? Like gluons. The reason they don't stand in the way of these 3 quarks is because they have a full spin. Therefore, does not follow the Pauli exclusion principle. Fucks off right through them, right? They just exist, can't interact, but they do. Yeah? Heavier quarks make heavier protons and neutrons, and the gluon keeps them packed together. Done! Like your creepy uncle at, like, the family gathering. He's always moving through you. The leptons are also subatomic particles, but they don't exist in the nucleus. They're the particles that orbit the nucleus. The electron is a lepton, and its 2 more obese relatives, the muon and the tau, and of course, its 3 backwards cousins from the south, the electron neutrino, the muon neutrino, and the tau neutrino. These neutrinos have no charge and fuck all mass, but are often produced as a byproduct of nuclear reaction, so we keep them there for the participation trophy. And lastly, we got the W and Z bosons. The Z boso is like the gluon, except it regulates the weak nuclear force, but the W boson comes in 2 flavors, vanilla and chocolate, each respectively carrying a positive or negative charge. It's way heavy. I'm talking like Gorlock the Destroyer heavy, and can change the charge of certain subatomic particles, which is when we get to why these particles are put like this in the chart. Essentially, the W boson can toggle quarks from up to down, top to bottom, charge to strange, and vice versa. And this happens a lot. Here, we pretty much have described all the basics. Now we can get to the cool shit. The little bastard that I've been talking about here is a quantum particle of dark matter. Better known as the God particle, this boson is the particle that interacts with other particles to give them the property of mass, or gravity. It's probably better to say weight, but it interacts with everything, but also doesn't, because it is dark matter, which gets its name because we have no way to observe it, or its kind of matter, which means we know the fucker's right there, but we just can't see it yet. Now we get to antimatter, which sounds far cooler than it is. All these terms, like quantum particles, dark matter, antimatter, they're very straightforward at the end of the day. No, an antimatter reactor isn't going to quantum nova the planet if you sneeze on it. Dark matter drives aren't going to create black holes on you. The quantum charge or the flux capacitor, that they don't mean shit. All these Hollywood-appropriated scientific terms just describe the thing that exists and that makes us up. Dark matter is just particles we have no way to observe at the current moment, and antimatter is the same as regular matter, just with an opposite charge, anteified. That's it. That is absolutely that's quantum physics. I'm absolutely sick to death of hearing these terms bastardized by actors and directors for cool, geeky things. But I swear to fucking God, if I hear someone put quantum in front of another stupid word, I'm gonna hurl the most available quantum brick at the quantum television.
Rocky Roll McDonald's! Rocky Roll